All right, I just received an email from Professor Tajinder Singh, and just saying thank you. I accidentally, when I just did this live stream with him. I'm following up on this. I was researching this whole idea of microscopic virtual black holes, and I discovered this paper, and the main author died before the paper was finished publishing. And basically, they're arguing that the origin of all quantum particles is black holes, and this is what Jean Chiron was arguing before. So, I mean, I knew this already, and then when I saw the Jack Sarfati's book, Beyond Spacetime, with Fred Alan Wolf, then, that was another example of scientists making this claim that something I had already experienced from meditation, that the wormhole exists at the quantum level, thereby corroborating the Einstein-Rosen equals Einstein-Podolsky-Rosen. And my own quantum physics professor, he discussed this in a footnote in one of his papers in Herbert J. Bernstein, that Einstein actually considered this as a possibility. So I was researching this, and then all elementary particles as stabilized black holes. In other words, the black hole had evaporated into a particle. Now, there's this paper here, traversable wormholes, and they're trying to develop the same idea. I'm not going to talk about that right now, but I found this Russian paper. I couldn't find anything else on this, but this is the same concept. This is actually from Louis de Broglie's law of phase harmony, that the dark energy is actually the speed of light squared divided by the particle velocity. That was de Broglie's original claim. And then Professor Hiley has proven that Dirac's relativistic quantum equation is the same as Bohm's model, and so they're basically saying, this is the non-locality at the, it's the truth of the universe. This is what Paul S. Wesson was also saying, the astrophysicist. Okay, so that's what left me with this. And what was I? Gerard de Hooft. Oh, I thought I cited his I must have. I think I probably put that in my.
Okay, just letting people.
I think I put that in my notes. Gerard de Hooft. Anyway, where did I leave that? Gerard de Hooft, he gives this amazing. Is it in here? Oh, I did a follow-up on this. Sorry, I added it to my Gerard de Hooft blog post. So, when I discovered his paper, and I couldn't read his paper, but they said it was based on this lecture. And so then I found his lecture. And here's this lecture. And he finally explains his big debate with Roger Penrose. He explains what he meant by this. So he's saying the same thing. You know, these black holes are actually everywhere, and it's based on the same secret. This is literally the yin yang right here. This is noncommutative time and frequency. Right there. So this is beautiful. I mean, I think Gerard de Hooft has really figured it out. The only thing he's not using the non-commutative math. He's using the Fourier analysis. So, and he admits, you know, he's got to still work on the model. So he explains it all right here, and I'm not going to read through all this because it's complicated, but it's fascinating. His way of the reason that Penrose was freaking out was because, you know, Gerard de Hooft didn't explain all this to Penrose, you know, when they had their little debate. Okay, so this is the 720 degree spin, and I sent this to Professor John G. Williamson, and he confirmed that this is the same model that he's relying on, that the electron is actually two 1/2 spin photons. And this is what de Broglie had originally argued, but he didn't have a geometric topology, you know, to explain it. And this is the same thing as a long con. You know, it's non-commutative. It's this non-commutative torus, the donut, as if based on the fifth dimension. So you have this the SU2 covering of the SO3. So that makes it a donut instead of a block sphere. Okay, so that's citing this paper right here. And I sent that to Professor John G. Williamson. He responded, like I just said. And one thing I haven't mentioned is, Gerard de Hooft says it's taking place at the microsecond, which that confirms the meditation experience, because that's the ultrasound frequency. So this is just like, it's really wild. And okay, so I already went into that before. Now, okay, so here's the paper that cites Professor Singh. I just sent it to Professor Singh, and he thanked me for it. So basically, this is what I had just mentioned this in the notes on the
Hello.
I just posted this in the comments here. Anyway, not that comments. Yeah, it's right here, this whole thread. So I posted, first I said, I am okay, right here. It turns out that in graphene, the electron acts like two-dimensional photon with 1/2 spin. So I put that 16 hours ago, right? And that was based on this research I had posted here. I can't remember which one. Well, anyway, one of my previous blog posts. I was just on that. Yeah, right here, graphene. The electrons in the thin layers of graphene behave like massless particles. Thus, when electrons are forced into a practically 2D surface without volume, they behave more like photons. So then the photons have essentially a two-dimensional topology. But that two-dimensional is actually this 1/2 spin. They're in the fifth dimension. In other words, the two dimensions are in time and frequency, and that's it. So that brings us back to this. So the graphene is testing this, and they call it torsion. And they based it on this whole model right here. They call it the idealized time loop. So they're going to use the graphene to test this time loop that they call torsion, which is actually just noncommutativity. So they have it right here. They have at 0 time, and then they have the particle goes the opposite way. Then the hole, the energy hole, and this is exactly what Gerard de Hooft is talking about from Dirac, the energy hole and the particle, and he's saying that is what the eternal black hole is. It's based on this secret of time. So there's this total convergence of all these people, making the same. So it's right here, Dirac time loops. So I just emailed these guys because they cite Professor Singh, which is, it's really stunning because I looked for any citations of Professor Singh and I could find 0. I could find no, and that made me, I got kind of frustrated by that because I'm like, well, I had some critiques of him a bit, but here we go. Oh, it's actually in this paper. So, but I thought, he's doing a good work. And the thing is that this paper, I think this paper's unpublished. Is this still unpublished? Because it didn't come up in Google Scholar when I cited it. Let me see if this is in Google Scholar. Hold on, let me Google Scholar. Cited by 3. Well, see, MDPI. I don't know what that is. Universe. Spinner. Yeah, that's a preprint right there. So they're in universe. And then universe. I don't know what universe is. This is some kind of... Anyway. Submit to this journal. Oh, it's open access. See, that's probably why. It didn't get listed as. Yeah, I think it's more like a preprint. Anyway, So it's like this really exciting convergence. And so that this, yeah, well, I'm not going to get into that either. But I'm just going to leave it at that. So here's the quote from, although this is a theoretical, so we can use basically they're saying you can access this black hole you can create this black hole time loop, and that all matter is actually a quasi-matter, just like graphene. And this is what this ties into Penrose and Hameroff, the quantum biology. They're basically saying that the microtubule with the tubulin is like graphene as a metamaterial. So they're saying that the creation, the evaporation of the black hole is an effect of the Pauli exclusion principle. Now, what's fascinating about this is that noncommutativity goes beyond the Pauli exclusion principle as non-locality, and that's what enables the transversable wormhole based on a 1/2 spin. And I did a blog post on that. Let's see. Yeah, here we go. I think this is the one I did. Weak energy wormholes. This is it. Here we go. So John G. Kramer, he says, if you use the 1/2 spin, you can create a weak energy wormhole. And this has always been my point, based on the music theory as non-commutativity, that it would create these wormholes, and this is what I proved, through my own meditation experience. I mean, I literally experienced the space-time vortex from the non-locality. Their calculations assume that the matter components of the wormhole are two Dirac fermions arranged to have opposite spin. The resulting wormhole is threaded with the negative charge and emerge with the positive charge. The two fermions occupying the wormhole throat have entangled wave functions and appear to observers at the two wormholes as. So this is exactly what Gerard de Hooft is stating is his eternal black hole. And so here we have another one, and they tie it right back to graphene. Such an effect may be realizable in graphene. So this is a totally different research group. Three other different people than these three. Are any of these the same? Wait. Nope, none of those are the same. Right, so you got six people right there saying the same thing. We consider a static wormhole as a waveguide. The wormhole, and this is what Jack Sarfati is saying also, that graphene should enable the creation of a wormhole warp drive. All right, I'm going to leave it right there. Thanks.